For the constant resistance to motion of magnitude 350 newtons act on a car of mass 1250 kilogram, the engine of the car exerts a constant driving force of 1200 Newton. The car travels along a road inclined an angle of theta with the horizontal, and the sine theta value is given. It is 0.05. Find the speed of the car when it is moved to 100 meters from rest, and in the following cases: the car is moving up the hill and the car is moving down the hill. So first of all, we need to find out the speed of the car when the car is moving up the hill, that is in this direction. So first of all, we need to figure it out that what are the different forces which are acting on this car when the car is moving up the hill. So the first force is given that there is a constant resistance force of 350 Newton. So this is 350 Newton of force. Maybe denoted by R, and acts on a car of mass 1250 kg. So this mass of the car is 1250 kg, and we need to resolve this into the two components. So this is one of the component, and the second component is in this direction, and this component will be W sine of theta, and this component will be equal to W cos of theta. Now there is a driving force which is acting on the car, and this driving force is in this direction. This is the driving force. So these are the forces which are acting on this car when the car is moving up the hill, and we need to find out the speed of the car when it has moved 100 meters. So let's find out the net force which is acting on this car when it is moving up the hill. So since the car is moving up the hill, so there must be a resultant force in this direction. So the net force will be equal to driving force acting upward, and the two forces are resisting the motion. One is this force, that is 350 Newton minus 350, and another is the component of weight, that is W sine theta. It is also resisting the motion, so minus W, or you can say mg sine of theta, and according to Newton's second law of motion, it will be equal to ma. Now we need to put the values in order to find out our required variable. Now it is given that the driving force is 1200 Newton. It is given. So this is 1200 minus 350 minus m. M is given. It is 1250. G is 10. And sine theta is given that its value is 0.05. So this is multiplied by 0.05, and this is equal to m. M given 1250 and A is unknown. So we will get an equation in A. Now simplifying this equation, you will get the value of A after the simplification. The value of A will be 0.18 meter per second square. So this is the acceleration of the car when it is moving up the plane, inclined plane. Now we are asked to find out the speed of the car when it has moved a distance of 100 meter. So the distance S is equal to 100 meter. And since it starts from rest, therefore U is equal to 0. And we need to find out the final velocity of the car. Now we have got equation of motion, that is V square is equal to U square plus 2S. We need to simply plug the values and find the answer. V square, now U is 0, therefore U square will be also 0, so 2. A, the value of A is 0.18 and distance is 100. So V square is equal to, you need to multiply all these values, you will get 236, and by taking the square root you will get the value of V, and that will be equal to 15.4 meter per second. So this is our first part in which the car is moving up the plane. Now in the second part here, the car is moving down the plane. Now the driving force will be in this direction because the car is moving downhill. Now since the car is moving in the downhill, therefore the resistance force will be acting in this direction. This is R now. R always act, resistance force always act against the motion of the car. And again we need to resolve the weight components. This is our first or second component. This may be W sine of theta, and this is W cos of theta. Now here in this case, this W, the component of W, that is this component W sine theta, is making the body move. It is assisting the motion down the hill. So its direction is in the downhill direction. Therefore, and since in the second part we are assuming the car is moving downhill, so therefore these two components, this component or this driving force and this component of the weight will be taken as positive, and this component will be taken, this resistance force will be taken as negative. So dF plus W sine theta, these are contributing the motion, and minus R because it is trying to resist the motion, and that will be equal to ma according to Newton's second law of motion. Now we need to put all the values. We have got driving force is 1200, and this is mg, and m we are given that it is 1250, so it will become 1, and the value of g is 10, it will become 1250 0.00. Sine theta value is given. It is multiplied by 0.05 minus r. R is also given, that its value is where is R? Here is R, 350 Newton, and this is equal to M. M is given, that is 1250, and E. And by simplifying this equation, you will get the value of acceleration. And in the downhill case, the acceleration will be 1.18 meter per second square. So we have calculated the acceleration from this equation. And now we need to take the equation, one of the equation of the motion, and plug the values and find out the final velocity in this case. Now again, S is 100, A we have already find out, initial velocity is 0, and we need to find out the value of V. Now again we will be using the equation of motion. V square is equal to U square plus 2s, and V square, U square is 0, and now 2 into A. What is the value of A? A is 0, not 0 point, it's 1 point multiplied by 1.18 multiplied by 100. So V square is equal to that will become 236, and this will become 15.4 meter per second. Well, in this case, I think it is not 236. It is it will have a different value. It will have 0. It's some other value, I think so. V square is equal to 36. In fact, it's not 236. It is 36, and the value of V will be equal to 6 meter per second. So here I should erase this stuff. So it is 36, and V is equal to 6 meter per second. So in the up hill motion, the velocity will be 6 meter per second, and in the downhill motion, the final speed of the car when it has traveled a distance of 100 meter, it will be 15.4 meter per second.